Hello everybody, this is Rohin from Braining Solutions. Today I am going to tell you something about the front-end VLSI design. In this tutorial I am going to use the basic gates and we will design our circuit using the Xilinx tools in VHDL language. Later on we are going to test our circuit using the test bench, and after then we are going to embed our design onto the FPGA chip and see what's happened. So let's get started. First of all, double click the project navigator. So it's opening the previous project. We're going to make a new project from the scratch. First of all, click File, then New Project. We have to give the name of our project. Let it be Gate, and we will change our location. Let it be on the desktop. We'll make a new folder here. The name may be Brainiac. Double click. Okay, we can make a new folder within it. Let it be VHDL for proper management of our designs. Press OK. Okay, the top level source type is SDL, it's fine. Press next. Okay, these are the device properties, that what type of chip we are using. So we are using the Spartan 3 family. Device is XC3S200. Package is Tetra. It's with 144 pins. Speed is specific for this chip. The synthesis and simulator tool will be in VHDL. It can be Verilog also. Preferred language is VHDL. Okay, everything is fine. Press next. Okay, we have to create a new source. Click new source here. Now since we are going to design our circuit onto the VHDL language, so we have to select the VHDL module for it. Let the name for that file be gate. We have to add this file to the project. Now it will have the extension of .vhd. We'll see it later on. Okay, the different port names. Let it be 2 input gates. So A with direction input, B with direction input. We can define the outputs within a single file. Let it be Y and the direction is output, Y or the direction is output, and Y not, the direction is output again. Press next, finish, then next. Okay, if you want to add any existing sources, you can select this thing, we don't require here. Next, and then finish. Okay, so this project has opened. Double click on it. This is gate.vhd. Now it's having the extension of .vhd because we are using the HDL language is VHDL. If we are going to design our circuit onto the Verilog language, then the extension will be .v. Okay, so these are the predefined libraries. It has already defined it. Entity has been defined. Entity gate is port A in STD logic, B in STD logic, Y and out STD logic, Y or out STD logic, Y not, out STD logic, AND gate. Architecture behavior of gate is. Now we have to begin our coding here. So we will define the output, and it should work like this. This is assignment operator A and okay, this is A and B. Since AND is a keyword, it is in the color blue. Okay, next is Y OR. this is A or B, next is Y naught, this is okay, it can be not of A. So our coding is complete for at the output Y, and the output practically it can be some LED, and for the inputs it should be some switches. So be Y of A. Now we have to save our project and then we have to synthesize it. We can do everything using the generate programming file. Just double click it, it will do rest for us. Now in the console window you can see that what's happening during this. Okay, so it is completed. It has been generated successfully. The green ticks means that everything is fine. Let us suppose we do some syntax error here. We have forgotten to put semicolon here. Then let's see what happens then. Now these ticks will be converted into question mark, and then we are going to double click it. Now since there is an error, it will stop at synthesize only. It will show the red cross there. That's some problem is there. You can check the error by clicking this thing, and it's showing that it is expecting semicolon. Before what? Because it is directing the point 42. Before this it was expecting a semicolon. Okay, so again let us correct this thing, save it, and then double click the generate programming file. You can see the console window here for more information. Okay, so everything is fine. Now we have to check whether our code is working fine or not. For that we have to simulate this thing. So we are going to simulate this design using a test bench. For that you just click here, gate, and then right click, new source, and then since we are going to make a test bench in VHDL language, click here. We can give the name to it. Let us suppose this is test. We have to add this thing to the project. So we have to associate this with our design. It's gate.vhd. So next, and then finish. Okay, one thing is more that we have to go for sources for behavioral simulation here. Now we are having this test.vhd. You can click it here. You can see the predefined code here. It's library, different libraries, entity, and then architecture. We have defined the component with name gate, and yes, we have it's predefined the signals, various signals, inputs and outputs. Then begin, we have port, the various ports here. Okay, we don't require the clock here since it is not defined here. We can just delete this thing. Here's the process. We have to define our code in the process. Just delete this thing again. We'll make our own code. We are going to wait for 100 nanosecond, let's suppose. Define the inputs. A is not of A and process. That's it. Now what it will do, at every clock cycle it is going to check for this thing. At every step it is going to check, execute this process. It will wait for 100 nanosecond, it will invert the input for A. So it is going to be like a clocked input to it. We have to design some another process. Let us copy paste this thing. The name cannot be same, just give any name to it. So wait for, let us suppose it is going to be for 50 nanoseconds. We have to change it from B to not of B, and then save this thing. The code is complete. Save it. Now you have to press this thing. It's test.vhd. Since it's our test bench, and then click here. Let us check for any of the errors. So check syntax completed successfully. Simulate it. Double click this simulate behavioral model. It will open the iSim window. So you can float it for the complete window. Now press here for the full view. So this is our input and output. You can check that after every 100 nanosecond the inverting, this A input is inverting after every 100 nanoseconds. Now for B, after 50 nanoseconds, since we have defined for wait for 50 nanoseconds, it's inverting. You can give the default values also. Default values are 0, it was, but if you want to have some another value, like you just don't want to make it like a clock cycle, you just can give A is equal to 1 or 0. It depends on your specifications, but this is a good simulation inputs. You can check every type of behavior here. Now for Y and, it is, you can see here, for Y and it is going to be 1 only when both of the inputs are 1. For Y OR, if any of the inputs is 1 out of A and B, the output is going to be 1. And for Y naught, we have defined Y naught as not of A. So this is when A is 0, then Y naught is 1, and vice versa. So our simulation using the test bench is complete. Next, we are going to check our design on the FPGA chip. Go towards your VHD file. Now you can see that we have already generated the programming file. You can check the design summary and reports for it by clicking it here. Now the main thing is that since we are going to embed our design onto the FPGA chip, so the important thing is that we have to take care of the inputs and outputs of the FPGA chip. Let's see it here. Now by default it assigns some of the pins to the FPGA chip. In this case, okay, it has given P127 to Y0, 128 to input A, 129, 130 to outputs, and 131 to input. So now since it depends on our development kit, now for I do have the inputs and outputs linked towards the different LEDs and switches. Now you can see that the input and output pins, the LEDs are connected towards 14, 15, 17, 18, 20, 21, 23, 24, 50 and 53 input and output pins. And the switches, this is P25, 26, 27, 28, 30, 31, so on up to 103. You can see it here. So we have to give the inputs and outputs toward this pin, not here. So to do this thing, you can click it here, right click, new source. Now we have to give the constraints file for it. File names can be the pins. Let's suppose it's pin, next, finish. Now you can see that it's the user constraint file, UCF. It is the new file has been generated within this gate.vhd. Just simple click here and then edit constraints. Now you can define the different inputs and output pins by writing it here. Since we want to connect the A and B towards the switches, let us suppose we are going to connect the inputs towards the switches P26 and P27. We do have the two inputs, so we have to give two input output pins towards it. So we can do it. Which one? It's A. We have to give the location. It's P26. You can copy paste this thing. Since we do have 5 inputs and outputs, for a quick process you can do it like this. So the next pin is B and this is P27. The various outputs Y AND, Y OR and Y NOT. The various locations that we can give P14, 15 and 17. So this is P14, 15 and 17. Save it, click it here. You can see that synthesize is fine, but we have to generate the programming file again. So double click it here. Now after it, double click design summary reports. Let's see where are the inputs and outputs now. Here it is. For P14, 15 and 17 we do have the outputs, and for P26 and 27 we do have the inputs. Now since the inputs and outputs are defined and also the bit stream file has been generated. Now this is the file that is going to be embedded in the FPGA chip. This is the file that this FPGA chip understands what is this FPGA chip is going to perform. This bit stream is just nothing but the streams of various ones and zeros. So let us embed this design to our FPGA chip. Open the programming for it and look for the bit file. It is generated at Brainiac VHDL gate.bit. Now select it and program it. Now the bit stream file has been embedded into the FPGA chip. Here P26 and P27 are inputs. P26 corresponds to A, P27 corresponds to B, and we do have the corresponding outputs at P14, 15 and 17. P14 is for Y AND, P15 is for Y OR, and P17 for NOT of A. Now since both the inputs are on now, so AND gate is going to be high, OR is going to be high, and P17 is NOT of 1, that is 0. This is going to be low. Let us switch off this P26, you can see that for P14 to be high, all the inputs have to be high, and for P15 to be low, all the inputs have to be low. So it's working fine. You can see for various inputs and outputs. I hope the tutorial is helpful for you. Stay tuned for my next tutorials. Thank you.